Okay, so in the last lecture we saw the shapes of dxy, yz, xz, x minus y square and z square, in which we only saw the positive and negative signs on lobes for dxy, yz and xz. So now we will be seeing or determining the positive and negative lobes in case of x minus y square and z square. Okay, so we have x minus y square as something like this. The shape would be electron density across axes. This is the shape of dxy. Okay, so this is the shape of dx square minus y square. Okay, so here it would have two nodal planes as we have already discussed. Okay, with the angle 45 degree in the same plane. Okay, so now actually discuss the cases for determining the positive and negative signs on the lobes of the phi. Okay, or let's determine the sign of phi for each of the lobes. This is the another way of putting this. So first case is we have x. So let's say for positive x-axis we would have here, for positive x-axis we have x square minus y square. X square is positive, y square is 0, so it would be, sign would be positive. Second, for positive y-axis, x square is 0, y square is positive, so it would be negative. Okay. Third, for negative x-axis, sign would be x square minus y square. This would be again positive. And fourth, for positive or rather negative y-axis, sign would be x square, which is 0, minus y square, which is minus square, which should be again minus sign. Okay, so let's put the signs correspondingly. This was positive, this was positive, this was negative, and this was negative. Or in other case, both positive and negative y-axis sign was negative, and for both positive and negative x-axis sign was positive. Hence this is the sign of phi for the lobes in x square minus y square. Let's deal with the case of dz square. So the shape of dz square would be something like this, in which we have electron density across z-axis and we have a spherical electron density across dx square minus y square and dz square minus x square. So we'll be looking into it, but for timing, this is the z-axis and this is the spherical. So in 2D it is just looking like a ring shape, but in actuality it is a spherical electron density. Okay, so this is the shape of dz square. Okay, so it doesn't have four lobes. So for determining the sign of phi, so there are only two cases here. First is for positive z-axis, it would be z square, or positive square, it would be positive only. And for second, for negative z-axis, again you would be having negative square, which would be again positive. So the sign of phi would be positive in both the lobes. So the spherical or the ring which you are seeing in the diagram can be split into dz square minus x square and dz square minus y square. So both are actually included within the same shape, which is z square only. So these two are in actuality in circular form. So that shape which you are seeing in the ring shape is actually a circular form comprising z square minus y x square and z square minus y square, and they don't combine to form four lobes. Okay, so just to write us as a summary, that number of nodal planes in orbit of a subshell is number of nodal planes in orbit of a subshell is equals to L except dz square. Okay, and number of lobes in a orbit, or rather in a orbital, not a orbit does not make sense here for a subshell. Number of nodal planes in orbital, rather not nodal planes, number of lobes in orbital of a subshell would be, this is except dz square, so this would be equal to, again, so number of lobes would be 12 except again dz square. Okay, so let's see this with the help of example. So I hope you remember that for the L value for s orbital would be 0. So now number of nodal planes in s orbital was again 0. So and number of, what is the value of L for p orbital? Value of L for p orbital would be 1, and the number of nodal planes in case of p orbital was also 1, and then for z orbital the L value was 2, and the number of nodal planes except dz square was also 2. Means in case of x y y z x z x y minus y square, the number of nodal planes were 2, but only in dz square they were 0. Okay, so they were not following this equality to L. And similarly the number of lobes would be again dependent on the value of L except dz square, that is for the value of L equals to 0, or the s orbital number of lobes were again 0. For p orbital, the dumbbell shape, the number of lobes were just double the value of L, as in the value of L for p orbital was 1 and the number of lobes were 2. And similarly in z orbital also, except dz square, in all the cases the value of L was 2 and the number of lobes were 4. Okay, so now let's see for shape for F subshell, which we are not going to see, but as it is out of syllabus for the syllabus of JEE, means as far as the syllabus of JEE is concerned. So now let us see for F subshell, we would be having 7 orbitals, which is 1 2 3 4 5 6 and 7. Okay, so this is -3 -2 -1 0 1 2 and 3. So this is F subshell, and here the number of nodal planes would be equals to, here it follows, and the number of nodal planes would be equal to L, which is 3. So L falls up, F subshell is 3. Okay, and it is ungeared, as the number of nodal planes are not equal to, or are not even, they are odd in number. So just remember this, as we are not going to see the structure, we have to just remember the number of, or other, whether it's geared or ungeared. Okay, so before ending the lecture, I will just like to talk about the formation of nodal cone in case of dz orbital. As we saw that dz orbital does not have a nodal plane, but it does have a nodal cone. So let's actually see the structure of dz square first. The structure of dz square is and we have z-axis here and x-axis here. So now let us determine the nodal cones here. So nodal cone formed here would be something like this, which passes through the ring, means the intersection of the ring, and let me draw it something like more bulging out. Okay, so nodal cone would be something like this. Okay, next it would be again passing through. Something like this. Okay, so this is the nodal cone formed here. Okay, so here the formation of nodal cone is here. Okay, in dz square orbital. So with this we come to the end of this lecture. So basically this is the y plane only. So with this we come to the end of this lecture. In the next lecture we'll be seeing spin quantum number. Okay, so till then, good luck and goodbye.